Welcome to Lab 1. This is just going to be quite a different semester. Usually I do this stuff face-to-face, so I figured it's probably best to record this and share the recording instead of doing a walkthrough with the class online, because some of this stuff you might want to go over again. So I figured I'd just do a couple of these videos for the labs and help you walk through what the requirements are, how to do the lab, how to execute Eclipse, and etc. Right? So what's our starting point? Assume that you already have the setup completed, you already have Java 14 installed, you already have Eclipse installed, and you may or may not have used Eclipse before. So let's assume that you haven't used Eclipse and you're ready to get started with Lab 1. Okay, so let's get started. I'm going to start Eclipse. I already have a session of Eclipse running, but that's cool. I'm using the current IDE for Eclipse. It asked me to create a workspace or attach to a workspace, and let's see. I'm gonna create a workspace. Doesn't matter where the workspace is. It's basically a folder on your machine where it's going to store files, basically. And I'll start, and it's going to start with the startup screen in a second. It's coming. It's usually not this long. All right, here we go. Startup screen. Again, you already have Eclipse installed. You already have the install completed. I'm going to close the startup screen, and I'm going to close some of these other windows that I never used. The task window, the outline window. I've got the Package Explorer window here. I'm in the Java perspective. I am ready to go. Let's take a look at the lab. So what I asked you to do in Lab 1, and this may change between now and the time I actually start class. It's the end of July. Class starts at beginning of September. So I'm going to make tweaks to this lab. What I'm going to ask you to do is create a new project, a new Maven project. And I bet you 99% of you never heard of Maven before. We're going to use it in this class, and I'll explain what Maven's for. But we're going to create a Maven project called Sudoku BLL and create a new class called Latin Square and some methods in Latin Square. So the Java class that we're going to create is Latin Square. This is the class diagram of the Latin Square and the methods that I want you to create. Okay. Like for instance, this video is going to be this video. I've got a little bit of work to do in the lab, but let's get started. So I want you to create a new Maven project called Sudoku BLL. Let's do that. So I'm going to say new. Start it again. New. Other. Not a Java project, but other. And under other, I'll have Maven. And I'm going to select the Maven project. Click next. All right. And again, I'm going to just do it. You'll know what Maven does over the next couple of weeks. But for right now, I'm going to say it's a simple archetype. Next. Now, I gave you the group ID and the artifact to use. I'm going to make sure I pick it from the lab. The group ID is going to be CISC edu. So I'm going to do CISC.edu. And the artifact I asked was Sudoku BLL. So I'm going to say Sudoku BLL. Don't change the version, don't change anything else, and then give me a finish. Okay, so what this thing should do is create for me a scaffolded Maven project. Now you see the defaults to Java 1.5. We're going to change that. Okay. Now I'm going to steal some code from my other project, the pom.xml, but I'm going to provide for you this pom.xml. Okay, it's going to be part of the lab. So when you see the lab assignment, it'll be under files in Canvas. When you see it, that's what this is. It's going to be the same thing. So I'm going to go to the pom.xml. This is just a dumb file, okay, an XML file. If you open pom.xml, I've got overview dependencies, et cetera, et cetera. I'm going to select this tab, which will show me the XML. You notice the group ID and the artifact ID is there. Oops, sorry. And the artifact ID is there. It also has some other stuff. And again, I'm going to skip over what other stuff is. I'm going to skip over what other stuff is and explain what Maven does later. But just for now, I'm literally going to copy, and I'm going to go back over to my new project. And this pom.xml is pretty much empty. I'm going to zoom in so you can see it, and paste. And then save this file. I mean, all I did was grab that pom.xml, copy, paste, and save. I got an error. Don't worry about it yet. Let's see what the error says. The project configuration is not updated yet. We didn't do that yet. So I got an error when I did that, but don't worry about it. I'm going to right-click the project and then say Maven Update Project, and click OK. And if it works, first of all, the error should go away, and Java now should be pointing to Java 1.14 or Java 14. So the way that, I'll give you a quick lesson in Maven. In the pom.xml, I'm telling it the Java version here. I'm telling it the Java version here. Java 1.14 points to Java 14. If I pointed it to 1.12, it'll point to 1.12. You get the idea. If we were starting on Java 15, it would be 1.15. Again, I'll explain to you what all these things mean. All these different tags mean over the course. If I look at my Maven dependencies, the dependencies that were in that pom.xml have been downloaded and associated with my project. My project is ready to go. Now, a couple of things. The Maven project, the simple archetype, if you look, it comes with 4 folders: source main Java, source main resources, source test Java, source test resources. This is the folder structure for a simple archetype. Depending on the archetype that you pick with Maven, it comes and it'll build for you a different folder structure. So, for example, if we were creating an Android project, the Android project has a different folder structure. It would spit out whatever the folder structure is for Android. Or if this was a web server, or if this was a web service, you get the idea. There's 1,001 archetypes out there. I could, if I had a server, like a dedicated server, I can create my own archetype. And instead of picking the simple archetype, I can make you select the University of Delaware archetype. That's cool. That's beyond the scope of this course. I gave you the POM. I'm never going to make you in this class figure out how to craft the pom.xml. I'll give you that. That's something I'll give you. Okay, so what do we got so far? I've got source main Java, source main resources, source test Java, and source test resources. Let's pop back over to the lab itself. And let's review what because I think it's going to be the same thing. Create a new Maven project. I gave you that. Replace the sample XML with the one provided. I gave you that. Perform a Maven update. I showed you how to do that. And you should have 4 folders exactly like this. Create a new package under the source folder. To create the package, right-click the folder and select new package. Call the package PKG game. Okay, so far so good. PKG game, let's do that. Right-click, new package, PKG game. Now, I asked you to make sure that create package info.java is selected. Let's do it, why not? And I'm going to say finish. Okay, and it created for me a package. And close this for a second. I have a package out there. And now I'm going to create my Latin Square class. Okay, so let's do that. New class, Latin Square. Very cool. Under package game, I've got a class called Latin Square. And what I'm asking you to do in the lab is to implement this class. And let's read this class diagram. Class diagram has 3 parts. The class name, and it's actually the class, the class package and the class name. Attributes and methods. So let's take a look at the attribute itself. That little red means it's private, Latin Square, int Square braces, square braces. So let's implement this very first one. Private, Latin square, private int, bracket, bracket, Latin square, semicolon. That is how you declare a two-dimensional variable. That's what that is, a two-dimensional integer variable. It's got a constructor called Latin square with no arguments, a public constructor with one argument, passing in the two-dimensional array. Let's create the constructor for that. You can type it in yourself, or you can use the IDE to do it. I'm going to say right-click and say source, generate constructor using fields. The first one's without a field, and it'll generate for me the no argument public constructor. I'm going to do the same thing, source, make sure it's selected this time, generate. And if you look, these two methods are exactly these two methods. Okay. Now, if you look at the class diagram, it'll tell you the accessor, in other words, whether it's public or private, static, or excuse me, public, private, or default, or protected. And it tells you by the different colors and the different shapes. It'll tell you the method name. It'll tell you the arguments that you pass to it. It'll tell you the argument that gets passed back, but it doesn't tell you the implementation. So if you look at the next one where it says get Latin square, passing in nothing and passing back a two-dimensional array, it doesn't actually tell you how it's implemented. The class diagram doesn't do that. That's what you got to do in this class, is figure out how it's implemented. If you look at this, though, I've got a getter and setter for the Latin square. I've got a method called has duplicates, a method called does element exist, a method called has all values, get column, get row, is Latin square, and contains 0. So this first lab has, including two constructors, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9 methods. Okay. Now you ask, like, what does this method do? How do you? I don't know what has duplicates means. I provided for you a Javadoc, which has this. It doesn't have the solution, but it has, like, you'll see. Let's open up the Javadoc. Now this would have been part of the lab. You would have downloaded this. In other words, it's a zip file. It'll be like lab1 doc. Download the zip file, unzip it, and then open up index.html. This is the Javadoc for my lab. Okay, package helper. I should probably update the, you know what? Instead of package game, I am going to call that package helper. Back in here where I said package game, we should probably call that package helper to match with the Javadoc. But here we go. Package helper. I've got two classes, Latin square and Latin square test. This is the unit test that you're going to do. Latin square. Let's go into Latin square. Latin square has fields, has constructors, has methods. And I did my best to give you a decent bit of Javadoc along with it for the methods especially, right? So method summary, let's take a look at contain 0. Contain 0 is a method. Contain 0 returns true if any element of the Latin square is 0. Okay, that's easy, right? So if any element of the Latin square is 0, contain 0. And by the way, the way the Javadoc works, it has links all over the place. So if I click contain 0, it'll forward me to like some more verbose documentation. Public Boolean contain 0. Contain 0 returns true if any element of the Latin square is 0. Returns true if any element in the Latin square is 0. So let's implement this one method. I gave you the signature. So public Boolean contain 0. And bang. Public Boolean contains 0. It's going to return back a true or false. If any of the elements in here are 0, return true or false. Okay. So let me think. It's a two-dimensional array. So what do I got to do? If I have a two-dimensional array, I've got to traverse the two-dimensional array by row, and then traverse each element in the row looking for a 0. Now, if I'm going to try to write this the most efficient way, let's say this was a 9 by 9 two-dimensional array, and the second element, the second column, first row is a 0. As soon as I find a 0, I'm done. I don't need to look at all 81 elements, right? I look at element 2. Element 2 is a 0. I'm out, like immediately, because there's no point in looking at the rest. I don't need to count the number of zeros. I just need to see whether or not there is a 0. The only time I'll get to the 81st element on a 9 by 9 is if every single one of them was 0, and I got to the last one and check to see if it's 0. Why do I care about 0 at all? The reason why is because Latin square is an int, right? And an int, the default value for int, when you declare an int, is a 0. So what I'm really looking for is that thing valued, right? If it's not valued, it's going to be a 0. All right, so what am I going to do? I'm going to pause my video for a second, stop sharing, because I'm going to steal the solution from my other lab. And getting there. Almost there. I'm going to start sharing as soon as I get it. Here we go. Not that. There we go. I stopped sharing because I didn't want to see the rest of the lab. So I'm going to paste that code. Let's take a peek at it. Public boolean contains 0. For int I equals 0, I is less than Latin square.length, I plus, a simple for loop, right? And then within the I, I'm going to loop for each I a j. And I'm looking to see if Latin square ij is equal to 0. If it is, true. Return true. So the return true, when it sees a return, it's going to return from that method. So if the second element was 0, it'll hit that return true. It'll stop iterating the fors, and it'll return from the method. This is the most efficient way. It's the most efficient way of doing it with primitive fors. There's other ways to look at to see if a two-dimensional array has a 0. You could use lambda functions, for example, and do this in one line of code if you wanted to. But if you're using for loops, this is pretty much how it's done. I'm looping for the length of the Latin square, and then I'm looping for the length of the Latin square. There's a minor flaw in this so far, and that is this assumes that the Latin square length is the same thing as its height. In other words, the same number of columns and rows. I don't have that in the code yet. There is going to be, in future labs, a check to make sure that you're not giving me a Latin square that's a 4 by 3, right? The Latin square has got to be the same number of rows and columns. That sounds like something that should be in the constructor, right? So in the constructor for Latin square, when you pass this thing in, there should probably be a check to say, is this thing a 3 by 4? Is it a 4 by 4? But it assumes that it's the same, right? Because if you didn't, one of these links wouldn't work, right? This length gives you the number of rows, I believe. The length gives you a number of rows on a two-dimensional. Anyway, so contain 0. I'm doing a simple nested for loop to check to see the value. And how do I know this actually worked? How do I know contains 0 works? Well, one way is to test it. So I could create a class with a main in it and test it that way. We're going to use unit testing in this class. So let's create a quick unit test. As a matter of fact, I'm going to steal some code, but let's start with this. Source.test.java. I'm going to create a new unit test case. There we go. And let's see if I can get this thing to work. PKG helper. And Latin square test. And we'll give it enter. Okay. Now it asked me to add JUnit 5 on the build path. I think I had JUnit 5 out here, but okay, let me give a okay to that and see what happens. Now, Maven is not going to like to see a default modifier on unit tests, so this class and this void, that's not going to work quite right. I'm going to give it a public class and a public void test. All right, let's see if this works as it is, right? I play it, it should fail. It fails because I'm using the fail method for unit test. But this is working as, believe it or not, working as expected. If I wanted to see if it would actually work, I would do something like assert equals 1, 1, right? This is asserting that 1 is equal to 1, which should pass, and it passes. Very good. What I want to do is test this contains 0. So again, I'm going to stop for just a second, and I'm going to steal my unit test for contains 0 from my real code, because I don't want to do this just staying on my feet here. Let's see, contains 0. Are you going to tell me I don't have contain 0 tested? I have. Of course I don't. Okay, so contain 0 is not tested, but let's test it. I'm going to steal some code, and I'll get it. I'll get it. I promise. Okay, I'm going to start sharing my screen again. 1 second. Okay, I'm going to call this contains 0 test 1, let's say. All right, and let's see what we got. Now I'm getting a problem where it's saying I don't know what Latin square is because it's in a different package. Remember I said package helper and package game. Now I'm forced to change the name of this stupid thing. So I'm going to say right-click package game, and I'm going to say, and I'm looking for it, refactor, rename. Give it an OK, and I'm going to call this PKG helper. And it's going to say, hey, if I change this, I'm going to have to change a bunch of places. Hit continue. PKG helper. That changed. Cool. Okay. Now this PKG helper, what didn't I like about this? Okay, right on. So now, this isn't the right code for the contain 0. This is calling the has duplicates. I copied it from a different method. But let's read through this. I'm saying contain 0 test 1 Latin square equals new Latin square. Okay, that's not going to work because that's a single dimensional array. I need to create a 2-dimensional array. You know what I'm going to do is I'm going to stop sharing for a second, but I'm going to put this other screen on my other window so I don't have to continue to stop sharing. Let me share again. There we go. Okay, so let me pull up a real Latin square. And I've got it. I've got it. Here we go. Let's read this now. Latin square equals new Latin square, int, my square equals, and this is how you do a 2-dimensional array. Now I'm going to say ls. Actually, when I say ls equals new Latin square, I'm going to say that. Okay, so what I did here was I created a 2-dimensional array with values, and I'm calling the constructor passing in that 2-dimensional array. That Latin square now has a 2-dimensional array. Boolean has duplicates, it's not has duplicates, it's B contains 0. And I'm not testing has duplicates, I'm testing contains 0. Okay. And I think I've got it. Let's see. Let's see what we got. I've got my square, which is a 2-dimensional array. First row has 1, 2, 3. Second row has 3, 1, 2. Third row has 2, 3, 1. I create an instance of Latin square, passing in my square, and I'm testing to see whether or not there's any zeros in it. And that B contains 0 better be a false. Okay. So then I'm comparing assert equals. I'm comparing what this should be with what I think it should be. So the expected value and the actual value. Do I have it backwards then? Expected value and actual value. Expected value and actual value. That's the same thing, false and false, but expected value and actual value. Let's test to see if this works. First, so I save it, no errors. I'm going to run it, and it's going to run, and it gets a green because it did come back with a false. Let's just, if devil's advocate, let's make this true, which I know should fail now. Watch what happens. It fails, okay? And it says in my messages, expected true, but was false. Expected true, but was false. So when you do a search and you're passing in two things, it's the expected and the actual. Okay, so let's put it back and fix it. Let's fix it. Very good. Okay, so we tested the positive case. We tested like no zeros, right? Let's test where I actually have a zero. That's why I call this test 1 and test 2. Here's test 2. Test 2, I'm going to insert a 0 right there. That thing has a 0 in it, right? Should find a 0. And I'm going to make that true. And then I'm going to test again. And it's going to work. And I know that it tested, let's see. I should have tested this one. Public void, test 1, test 2. Why do I only have one thing for test 1? I should see both here. Let's try that again. There, okay, whatever. It didn't it didn't show it before, but believe me, it's going to run both of those tests. So when I ran this, the JUnit runner ran this test, and it ran this test. Now you might want to actually test like edge cases to make sure that it's going to test, like it's selecting the first one. It found the one that's in the middle, but is it going to be okay with 1 at the beginning? Right. You might want to call this contain 0 edge case 1, and then the other edge case would be the last value. Very good. Now, remember I said it's expecting the same number of columns or rows. I'm giving it good data, but let's see what happens when I give it bad data. So, bad data, this has 4 rows and 3 columns. That doesn't work because it says index 3 is out of bounds for length 3. It's saying I'm trying to get to the 4th column in a row, blah 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 blah. This would have been found defensively, right? Because you would have checked to see if the same number of rows and columns are correct. So, but for right now, give it good data for now. I promise you, we'll check later. So that's how we implement contain 0. That's one of the methods. Give me a break, dude. That's one of the methods that's in this. Contain 0 is the last one. Has duplicates. I can think of 5 different ways to implement has duplicates. So what has duplicates is you're going to pass in a single dimensional array, and you're going to tell me whether there's a duplicate value in it or not, right? So give me a second, let's go. Has duplicate says I'm going to pass in a single dimensional array. I'm going to pass in, let's say 1, 2, and 3. That should return back a false. If I pass in 1, 2, 2, should return back a true. That's what has duplicates is going to do. Okay, let's go back over to the lab. Does element exist? You're passing in 2 things. You're passing in a single dimensional array, and you're passing in another int. So you'll pass in like 1, 2, 3, and 4. It'll be false. 1, 2, 3, and 2. It'll be true. Does element exist? Has all values. I'm going to pass in two one-dimensional arrays, and I'm going to check to see is everything that's in the first in the second. Right? So if I pass in 1, 2, 3, and I pass in 3, 2, 1, it should return back a true. If I pass in 1, 2, 3, and 1, 2, 4, it'll return back a false because everything that's in A is not in B. Get column and get row. Get column says, pass me back the column number you want, and it'll pass you back a one-dimensional array. So for example, in our example where I pass in 1, 2, 3, 3, 2, 3, 1, 2, and 2, 3, 1, each one of those is a row. So if I ask for row 0, it should return me back 1, 2, 3. If I ask for row 2, it should return me back 2, 3, 1. If I ask for column 0, by the way, 1, 2, 3 for row 0, 2, 3, 1 for row 2. If I ask for column 0, it should return me back 1, 3, 2. If I ask for column 2, it should return me back 3, 2, in this dumb case, 0. Back to the lab. Get row, get column. Is Latin square? Okay, so what is Latin square? This is a Boolean. What this is going to do is it's going to check to see. It's going to do a bunch of checks. It's going to run the other methods. Is what it's going to do. So the first thing it's going to do is do I have any duplicate values, right, in any of the columns or rows? Do I have a duplicate value in a row? I need to use get row. I need to iterate through each row and check to see if I have any duplicates. Do I have any duplicate values in the column? Same thing. Then I have to see, is every element in the first row in every other row? Is every element in the first row in every other column? And then lastly, check to see if I have any zeros. If all those things are true, it's a Latin square. If any of those things are false, it's not a Latin square. So is Latin square a little bit complicated? I wouldn't want to, in other words, if you didn't have the other methods to help you, it's pretty complicated. But you should be leaning on the methods that you created. Is Latin square, if you think about it, when you're creating this thing, it's going to be the last method you create, right? Because you need the other methods to exist before you can check is Latin square. All right. That's pretty much it. So with the lab, what I want you to do is implement these methods and then implement the unit test cases for each of these methods. Give me a positive case, give me a negative case, right? So I showed you how to implement contain zeros, but if you wanted to do has duplicates, you would pass in something that doesn't and something that does, right? If you're trying to implement is Latin square, you probably want to have a good Latin square. For example, our example again, that thing is a Latin square. 1, 2, 3, 3, 1, 2, 2, 3, 1. There's no duplicate values. Everything that's in the first row is in the second and third row. Everything that's in the first row is in the first, second, and third column. That's a Latin square. This is a Latin square for a couple of reasons. First, there's a zero in it. That's a problem. Second is the values in 1, 2, and 3 do not exist in the first row doesn't exist in the third row. So 1, 2, 3, 2, 3, 0 doesn't work because the 0 isn't in the first row. The reason why we check for the zeros is because what if this was 1, 2, 3 and this was, I'm sorry, this was 0, 2, 3 and this was 2, 3, 0. You see where I'm going with this? This 0 is not a valid value. It's not a valid is Latin square value. So we want to make sure that there's also no zeros. So Latin square is probably, none of these methods are very complicated. Latin square maybe 10 lines of code, something like that. If you're writing pages and pages of code, you're probably doing it wrong. Okay, so we've got the Latin square, we've got the unit test behind it. Commit the change to GitHub as a team. And what else do I want from that? I want the zip file from that. So I want you to extract. So remember how you do that? You say file, export, general, archive file. Yep, archive file, not a jar file. Break, dude. Next. This is in a different video, but I want this extracted as a zip file as well and attached as a zip file. Okay, pretty good walkthrough for lab 1. Should take, I don't know, hour or so, hour and a half. What do you learn in this? You'll learn how to do for loops. You'll learn how to traverse a 2-dimensional array, which isn't that hard, right? It's just same thing as 2 1-dimensional arrays. Any other questions, let me know. I'll be on office hours. The TAs will be on office hours, Piazza, the rest of it. So getting started. All right, guys, have a good one. We'll stop share.